are tomatoes. And you probably understand that they're good for you, but you may not be able to understand why on earth we're covering them here on the Everything Electric show. But the reason is simple. These particular tomatoes are some of the most efficient tomatoes going, and they're still delicious. And the reason is because food production is maybe the ultimate test in converting energy from one form to another form to fuel for our bodies, i.e. food. It is maybe the ultimate test in sustainability, controlling biology with the use of physics whilst doing it in a financially viable way too. So, we have come to Windset Farms in Delta, British Columbia to find out how they're making this possible. Welcome to the Everything Electric show.
Our 3 free YouTube channels on EVs and clean tech are funded by our fun-packed test drive-tastic events in Farnborough, London, the Southwest, the North, Melbourne and Sydney, and next up we're in Canada for Everything Electric Vancouver. And new for UK viewers, you can now buy a battery EV and much more at everythingelectric.store. Now, back to the episode.
Windset Farms are leaders in sustainable agriculture and have been since they were founded in 1996. Now they specialise in controlled environment agriculture, which basically means producing vegetables in greenhouses. Now here they produce lettuces, cucumbers, tomatoes and peppers, and between their facility here in British Columbia as well as their partner locations elsewhere in British Columbia and Mexico and their own facility in California, they have 2,500 acres of greenhouse space, which is around the equivalent of 50,000 acres of field farm growing space. Now here, this facility is particularly exciting because it is the largest LED lit greenhouse in North America. Tell us about some of the sustainability practices that you've implemented here, because there's been some interesting partnerships, for example, with BC Hydro.
Sure, on the sustainability front, we look at the 3 main elements, obviously heating, irrigation and lighting. And so when it comes to lighting with BC Hydro, we use renewable power from dams here in British Columbia using LED lighting. And LED lighting is advantageous because we can control the spectrum, we control the intensity. They're way more efficient to run. They're about 45 to 47% depending on the fixture, on the spectrum you're running, versus a high pressure sodium lamp. They last for tens of thousands of hours versus 10,000 hours max on a HPS bulb, which is very inefficient. They produce less heat. So the crop you can put more installed capacity of more light per square meter onto the crop, which is great, and get more production. We have beautiful long days in the summer. We are at the 49th latitude, so we have beautiful weather and long days that give us big production in the summer. But conversely, in the winter, it's shorter days, lots of rain. So that's where the lighting comes in. And the advantage of being in a cooler climate like here versus California is, again, although they're LEDs, they do put out some heat, but it's so cold that the heat is advantageous to the crop, and we can add that light and get excellent long days in the winter and excellent production in the winter with the use of artificial lighting with renewable energy.
You also implemented something I think called a thermal curtain.
So we use thermal curtains and we use blackout curtains, or light abatement screens they're also called. The thermal curtain are on the sidewalls and the roof, and that is to keep the humidity in as well as the heat. And then we also can pull it back and let the natural light in the daytime. We also have a blackout curtain at nighttime when we're lighting so that we don't cause light pollution into the community. But the other advantage of the light abatement curtain is that it's white on the bottom side. So it actually reflects more light up and down in the crop off the ground cover that's white and the ceiling that's white with the screen. So that's what we use, light abatement screens and thermal curtains. There's two different screens going on at the same time.
There's also a pretty sophisticated water irrigation system, which I think means that you end up recycling 98% of the water used.
Yeah, so we use cocoa, which is an organic substrate from Sri Lanka. We make reuse of these coconuts that are made for coconut water or whatever they're used for to grow our roots in. The plants don't take up all of the water on the first irrigation drip, and so we collect that water. It's got nutrition in it that we provide. We then filter it, and we also sterilize it with ozonation. And that allows us to basically put the water back to the plants over and over until it's fully consumed, either in a tomato or evapotranspiration through the leaves cooling itself. Mm-hmm. So that allows us to utilize the water until it's fully consumed and not waste anything.
Agriculture accounts for around 10% of the world's emissions, and yet demand for food isn't going anywhere. And in fact, that demand has to be met on a backdrop of more extreme weather, more unpredictable weather, a political environment that isn't always conducive or helpful for food producers either. And so these food producers are having to implement solutions that are climate resilient, cost effective, and of course still prioritise yield and the planet. Certainly no easy task. Now this is all about maximising the yield of tomatoes, and in order to do that, that's about maximising the amount of sunlight, the amount of photons that these tomato plants can receive. Including, up here there are some windows that are frameless, and in being frameless, it increases the amount of sunlight that these plants can receive by 0.7%. That means a roughly 0.7% increase in yield. The columns have been painted white, again allowing for that reflection of the photons, allowing that light to bounce up and reach the plants. And in fact, there's an aluminium structure instead of a steel structure, which allows the beams to be narrower, again increasing the amount of sunlight that these plants can receive. But it's not lost on us that when it comes to fruit and vegetable production versus, say, beef production, the CO2 footprint is actually pretty low. We're talking about 2 kilograms of CO2 equivalent per kilo of fruit and vegetables versus, say, 60 kilograms for beef. So you might be thinking, why are we even bothering about this anyway? But we are in a greenhouse, which whilst that might be more efficient from a land use and also from a water use perspective, these structures do need to be heated, cooled and lit all year round in order to enable that year-round production. And that's where Windset Farms have done some really interesting things. Many of the sustainability initiatives that you've implemented here are sort of motivated by the fact to be just more efficient with resources to create a better product. Has that been the motivating factor, or what's driven you to implement some of this stuff?
Well, it's interesting because most of the time the sustainability initiatives actually are financially the right thing to do as well. Energy costs a lot of money, natural gas, the biomass, wood waste to heat the greenhouse. Water, we have to buy it from the city of Delta, which comes from the dams from BC Hydro in North Vancouver, I think. But all these things cost money. Fertilizer is very expensive now as well. And so by doing the right thing environmentally, we're also doing the right thing financially, because we save a lot of money on fertilizer, on water, on heating, and also building it close to the population saves us on trucking. So it's kind of it's built for purpose, and we do it for financial reasons and also environmental reasons, because the consumers like it and the buyers like it.
So we noticed that there are boilers, which are obviously biomass, and also you mentioned burning natural gas to produce carbon dioxide. Do you think that you'll be able to electrify either of those technologies in the future?
Well, we obviously could put electric boilers in. It's very expensive to actually take electricity to make heat for this type of application, because we also need the CO2. We need the carbon dioxide to get the production. In growing, back to the data-driven growing, you have to have 3 or 4 things running in congruency, and that is, your CO2 level, your plant temperature, your light level, and all of that has to be going in the right direction. And if one's missing, and one being CO2, you could have everything perfect, and you're going to miss a lot of production. So we would love to get a CO2 supply, and maybe this is policy driven, to get a CO2 supply from other industries trucked to us. And if so, there's a lot of different industries that put out a lot of carbon dioxide. We're one of the few that actually consumes CO2. We need it. So we would love governments around the world to find a way to get greenhouses lower cost CO2 from industry, and at the same time produce more production and help our industry get more production per square meter and a lower cost of tomatoes.
Now, we also hear about food miles all the time, and a lot of the produce that's grown here will actually supply British Columbia. So how important is that as when thinking about this whole ecosystem of production?
Yeah, I mean, we're always trying to be efficient with resources, and one of them, of course, is trucking. Trucking is an essential thing to get the product to the market, and we try to build our greenhouses as close to big population centers as possible. We do the same thing in California, where our greenhouse is in a state of 40 million people within a 2.5-hour drive, and here in British Columbia, we're 30 minutes of most of the distribution centers in the province. So keeps the diesel low, it keeps the trucking low, but also gets the consumer a much fresher product that has a better shelf life, and we can pick it at a higher color stage that tastes better.
You have operations in different locations across the world, and the things that you do there are going to be in part motivated by what's the financial and most environmentally friendly thing to do, but that's often going to be dictated by the policy environment that exists there. What are the key differences that you observe between your operations in California and your operations here in British Columbia?
When it comes to energy, there's no doubt that our electricity is much lower cost here than Pacific Gas and Electric in California. Even though they have a lot of solar and they have a lot of natural resources too, it's very expensive. So there's not a lot of policies supporting use of artificial lighting. And I think that Quebec and Ontario do have those policies. British Columbia, with their support of our LED lights, is clearly following suit, which is great to see. And that allows us to produce in Canada now in the wintertime, year-round, for BC consumers, which is terrific.
Anything that's better for the planet is also better for you. And I think that's a really wonderful thing to think about when it comes to making food production more sustainable, more resilient, more secure. And coming here today, it's been such a fascinating insight into how that process, in its pursuit of being more sustainable, is all about biology, physics, deploying innovation, about economics and policy. I have found this absolutely fascinating. I really hope that you have too. But do let us know what you think in the comments. Please do like and subscribe. And if you have been, thank you for watching.
Now visit electricvehicles.expert, where you can follow everything electric and keep current with Clean Technica, The Driven, Electrek, and many more.